2, live.
Hello, global supply chainers, and welcome to our third and last live event from SC0x. We are here today live from our cave lab at MIT. And I have today with me Chris Caplice. I have today with us Chris Caplice.
Yeah.
From he's our executive director from the Center for Transportation and Logistics, and of course your instructor for SC0x.
Yeah.
Thank you very much for joining us today.
I'm glad to be here. So you might be having an echo now. Is that getting fixed? Okay. So sorry about that. Glad to be here.
So thank you very much for being here. Our agenda for today is very clear cut. We're going to do a recap of SC0x, and Chris is going to provide some context of how SC0x and the other courses of our MITx program come together. And afterwards, we're going to spend time on the problems for practice that our learners have supplied with some pretty cool problems that cover a wide range of tools and methods that we have discussed here yet, and we're going to dive into some of them and discuss. And finally, we do a quick wrap up of our course. That's our setting for the next 60 minutes. So before we start, I wanted to start one of our polls where we want to see which of the methods that we have supplied as our supply chain toolkit in SC0x were the most interesting for your career. Just while we go through our recap, just vote on that, see where we end up. So Chris, want to start with your recap?
Sure. But also for Slido, you have the ability to enter questions as well. So enter those questions. We'll try to answer them. Best thing to get them in early, and we'll try to answer them all, but don't wait for the last minute. All right, SC0x. This is probably the first class you've taken, most of you. So you've taken some things out of order, but hopefully this is your first foray, and it's the most intensive course we have. So it gets easier from here. We hit you up front with all the math early. Not sure if that's the best, but that's the way we do it here. So you have all the tools. When you hit the other courses, 1x, 2x, 3x, and 4x, you're equipped. So there are really four main things that hopefully you took away and you learned from this course. And the first is one that we really didn't talk about. It's kind of like a Trojan horse. It's mathematical dexterity, because everything we do in supply chain is based on some kind of model. It might be a simple model, an analytical model, it might be very complex optimization model, but they all require functions. And so hopefully you got very comfortable with y equals f sub x. And y equals some function with some independent variable x. And it might be y equals x squared, y equals a plus bx, something like this. But hopefully you got comfortable manipulating algebra. And it seems trivial for you guys just coming from school. If you've been working in the industry for the last 10, 15 years, it gets a little rusty. So the real reason why we do all this math up front is to make sure you get that dexterity back. So you're comfortable hopefully with how to use functions, different forms of functions, and also approximations. These are some of the big things for mathematical dexterity. Then we went into three buckets of tools. First tool bucket is optimization. We spent the first half of the course pretty much focused on this. We started with a calculus, which is really just how you solve an unconstrained optimization problem. You want to find what's known as an extreme solution. It's a minimum or a maximum or an inflection point, which we don't really cover too much. But generalizing, you're minimizing cost, you're maximizing profit, or maximizing revenue. That's all you're going to see. And the big takeaway there is the first order, second order conditions, proving you're at an extreme point. And the second order tells you whether it's max globally or min globally. So that was the big takeaway, and you'll use that in SC1x because the fundamental inventory model that you'll learn very well and you'll tattoo on somewhere in your body is the economic order quantity, your EOQ. And EOQ is simply first order conditions for a maximum or a minimum cost of how much inventory to order. So that's starting off with optimization. We started unconstrained, and then we added constraints. So it became constrained optimization. And this is where we went into, we talked a little bit in some extra things about Lagrangians, but we really focused on linear programming. And this is where you have a bunch of constraints, you have an objective function, and you have to find the maximum or the minimum value subject to these different constraints. So you'll have the form min z equals f sub x, whatever the different x's are, and you're subject to maybe you only have a certain amount of supply, you have to meet a certain demand, your x's have to be greater than 0. We spent a lot of time on this. We showed it to you graphically. You should be very comfortable using linear programming. Then we spent more time on mixed integer linear programming. That's where some of your variables, instead of being continuous, are integer, or more specifically binary. And you'll see this a lot later on in some of the courses, because for supply chains, a lot of your decisions are, do I open this facility or not? And so the mixed integer linear program, or MILP, allows you to make those decisions in conjunction with how much should I flow. So you'll have both continuous and integer and binary variables all together, and the mixed integer linear program is a great tool. So everything we did in optimization is known as prescriptive. So these are things that'll tell you a solution. It'll say what the X should be to maximize or minimize. It tells you what the answer is. That's why you're using those. The next bucket of tools we focus right after the midterm, and that's probability and statistics. And these are more descriptive. They're describing what is going on. And so we talked about different distributions. The two biggies we hit were normal distribution, which you should understand the normal distribution backwards and forwards. It's used widely throughout supply chain. Maybe it shouldn't be, but it is.
It's our general assumption, right?
It's a general assumption that you're going to have a bell curve. So you should be really comfortable understanding that, because you'll use that throughout, especially when we talk about inventory. But we also talk about the Poisson, which is more a discrete distribution and you'll see that in slow moving inventory. And then I also talk my favorite distribution, the triangle distribution, which is a nice one for approximations, where you know a minimum, a maximum, and a mode, the most common value. From that, you can do a really quick probability distribution. So into that, then we characterize data, and the two big things for characterizing a data set, which you're all going to have to be experts on, because data is massive and ubiquitous. It's everywhere now. And so you have to think about the central tendency and then the spread, the dispersion. Those are the two key things you want to figure out. What is the average, and what is the standard deviation, or the range, or the interquartiles? So you want to have those two ways of characterizing the data. And then we spend a lot of time on hypothesis testing. We spend way too much time on chi-square tests and details with chi-square tests and all the infinite little details, p-values and things like that. If you're interested in that stuff, it is a whole domain. Same thing with optimization, but statistics is like its own world. So there's a lot of depth you can go into there. I wanted to teach you enough that you will, the amount that you'll see in practice, actually. So do many companies do actual hypothesis testing? Not really. But they'll look at the distribution. They'll want to make, if you do a formal test for like investing something to see does it do an improvement, you need to know how to do that framework. But it is not used, in my opinion, as much as optimization. Because again, those tools are more descriptive. They're describing what's going on. So we talked about optimization, probability, and statistics. In the last or the third set of tools is regression and simulation. And regression is all about it's prediction. And so you're trying to predict what the dependent variable y would be given a new set of x's. So we had y equals beta naught plus beta 1x plus beta 2x2 and so forth. And you have a bunch of data and you're calibrating the betas. You're coming up with an equation that you can then formulate or estimate a new y, a new dependent variable based on new independent variables. And we use this for a bunch of different things. And this is widely used actually in practice to understand what the effect of something is. I use it a lot for transportation. You can model transportation rates by looking at actual rates and deriving what that function looks like. It's pretty widely used. In fact, it's used a lot to develop what the relationships are going to be to feed into a simulation. The simulation is simply where you're simulating future behavior, taking one of those probability distributions. So if you assume demand is normally distributed, you can simulate a bunch of days of daily demand and see how your system operates. it's really good at understanding a really complex system. We'll talk more about that in later courses, but if you have a system that's simple enough where I can solve it analytically, like that economic order quantity that I talked about, where you want to find the optimal quantity to order to minimize my total cost, then I don't need to simulate. Simulations for those problems where it's too complicated to model exactly analytically. And so if you have something with many players going on, setting up a simulation, even in a spreadsheet, is sometimes very helpful. And it helps you give an answer of how the system will behave. Now, one of the things that people always have a hard time grasping is that a simulation will never give you an answer. It'll tell you, given this setup, given these policies, this is what happens. It'll never tell you the best. That's what optimization is for. That's a prescriptive set of tools. Regression and simulation are more predictive. Given that you do these things, this is your outcome. It'll never tell you what to do to have the best outcome. So simulation and optimization are different types of tools. In fact, there's some packages like Lamasoft where you do the optimization first, and then you simulate it to see how well it is for robustness. And so these are two sets of tools. They're not the same thing. You never use simulation to find an optimal solution. Okay, so how are you going to use these tools in the rest of the courses? Well, SC0x, you're going to focus in on forecasting demand, managing inventory, and planning transportation. Here, it's all about statistics. You'll use a lot of regression for demand planning. For managing inventory, it's all about unconstrained optimization. You're going to minimize cost. How much inventory to minimize my cost? We're actually going to introduce something called a news vendor problem where you have a single period. In that, you're actually maximizing the profit based on the probability demand, the demand distribution for the probability distribution for the demand. So it kind of combines the two. How do I maximize something, optimize something under uncertainty? And we'll talk more about that later. And for planning, we use a lot of what's known as total cost equations. It's just a function of all the costs for all your activities, and we try to minimize the cost or maximize the profit. So a lot of these, you just kept creating very simple mathematical models and either minimizing or maximizing. In SC0x, it's all about design. You're going to use mixed integer linear programs extensively. You'd use them to set up a network design, for production planning, for combinatorial options for procurement. You use it throughout. And then in SC3X, we do a lot of simulations, and it's a little more complicated than what we covered here because we have what's known as a complex system. So we get into system dynamics, but it builds on what we did for simulation. We'll show you a different type of simulation in SC3X, and we also get into risk contracts. And this allows you to use both optimization and probability. The question there is, how do I share risk in a supply chain? So it uses these fundamental tools that you've already mastered in a much more complicated setting. And then in SC4X, we kind of take it to a next step. Because when we talk about data in this course, we might give you 100 lines. You know, these are little baby data sets. And we do that so you learn the concepts. In SC4X, we give you hundreds of thousands of data records. Because in a real situation for a company, you don't get baby data sets anymore. You get massive amounts of data. And this can be from point of sale information. This might be GPS pings if you're doing transportation. It can be signals from a machine if you have Internet of Things. So the amount of data is increasing. So we teach you how to do that, how to create databases, and then how to use machine learning. And so what we do in SC4X is take everything we've learned so far and show how to scale it. So all these techniques will be used and we'll add more to it. And so that's what we've done in SC0X. And that's kind of how we will use it for the rest of the course.
So it's still our toolbox for supply chain management, right? And we have that toolbox now with us and can use it to solve specific supply chain management problems, right? Shall we quickly take a look at our poll on different tools? And I think the learners have clearly voted.
They get to do 2 votes each.
Yeah, so they get two votes each, and I think simulation and constraint optimization are clearly their preferred parts that have them impacted most.
Well, that's too bad that you guys don't like approximations. Approximations it's a lost tool. Did you have to learn a slide rule?
Yes, yeah. We in engineering school. We did
Yeah,
that,
I still have my grandfather's slide rule. It's an 18-inch slide rule in a leather case.
and you can move that around.
The beautiful thing about it, it forces you to approximate, and so it's a lost skill. So whenever you do one of your problems for something, you should always think, what will my answer be in order of magnitude? It's such a good skill to have.
And it's kind of interesting that compared to the first round, first live event, where we asked essentially the similar question of what you are looking forward to the most, algorithms and approximations were more liked, but still simulation and constraint optimization were those that they were looking for the most.
And we snuck in hypothesis testing.
Yes. But it's not really interesting.
Someone is 3%.
3%, right?
All right.
Yeah. Okay.
So the good news is you'll see a lot of optimization. To be honest, simulation, we do some. We don't use it as much for the other parts of the courses because it gets, for a large problem, it gets very specialized. The software that we use for here, it's very intensive, to be honest. So we are more heavy users of constrained optimization and some regression, and everything else is pretty even.
Okay, good. We want to look at some questions, or no? Let me just quickly cover the one thing that is still ahead of you, which is the final exam.
Ah, that little thing.
And that little thing, right?
Just a little thing.
We're going to launch the final exam tomorrow at 1500 UTC. It's going to be open for just 1 week until 4th of July. And it's going to be, again, a timed exam. So essentially, it's the same setup that you have already seen in the midterm. So you have 4 hours to solve 4 problems, 3 mathematical and 1 checkbox.
And it covers all 8 weeks, right?
And it's going to cover all 8 weeks.
Okay.
So from the first day that we have presented content, it goes on to what we have seen in the last week.
And so would you say the final exam is comparable in format, level, and difficulty to the problems on the midterm?
Yes, so that's our objective, right? So we want to cover what we have seen. We want to test whether you have learned the contents, and it's going to be similar to what you've seen in the midterm.
One last question that came in. I'm just looking at the questions that came in for this. MD asks, is there any practice final exam, even from a different website or resource we could work through? I don't think we have one.
We don't.
But you know what? Here's what we do. We come up every time the exam is new, right? We come up with new questions, but you never throw a problem away, right? They become practice problems.
Yeah.
And so look at the practice problems, and they're going to be very similar to the types of problems. You should be comfortable with what we've been asking.
And you can go through the practice problems again, right? Just work those again if you feel that you have to look at them, and you will have a good set of training problems to work through.
So one last question about the exam. I'm just hitting the exam questions first. Being our first exposure to a final exam, we would like to know if there are any specific insights on what we should be concentrating on for better scores.
Well, that's something you have to take.
Yeah,
right?
do better. I kind of talked about what we'll be doing, and you know the areas that you're going to see. It's going to be very similar to the approach of the midterm.
Yeah, absolutely.
Right?
And in terms of content, I think you have given a good overview of what is important to us, how we think about the different concepts, and why we think they are important in terms of the supply chain toolbox. And I think that gives you a good idea of what you can expect. We are focusing on in the exam. We're not going to ask some weird side section, but we're focusing on what's important to us.
Okay. I can answer some other questions that are along these lines. Is that okay?
Sure.
So someone asked, Amrit Raj asked, are our practice problem scores accountable for the MicroMasters credentials? No, they're practice problems. We don't care. We don't look at them. You get no points. Hopefully you do them. They're there for your practice. But no points.
The only stuff you get points and credit for is doing the GAs.
The graded assignments each week. Yep.
Yeah, and do the midterm. And that's already your first point collection. And then there is the final exam that provides the largest share of points.
Right. All right. At a midterm, we had 2 attempts. At the final exam, is it 1 or same as the midterm?
No, it's again 2 attempts. We don't change the format. You're trained on a certain format. We've tried to educate you on that format. We're not going to confuse you with different formats.
The only difference will be when you take the CFX, the comprehensive final exam, and in that one, It's a little different. We don't have the nice green check of happiness or the red X of despair.
Yeah.
We just tell you that we got the answer. But for this, for the final, you have the checks and the X's, so you're good.
One thing that you should be clear on is when you start the exam, because you have that 4-hour time window.
Mm-hmm.
So once you click and start the exam,
Yes.
you need to continue and finish it, because the timer runs, and if you stop working on it, if the 4-hour timer hits, or if the clock hits the 4 hours, your exam is going to be automatically submitted. So you need to make sure that you have that window ready to work the exam.
Don't start working on it 2 hours before it's due.
Exactly. That's the second thing I wanted to make sure, that you start latest at 1100 UTC, because then you have exactly 4 hours until the final exam totally closes, right?
Yes.
Okay.
All right. What do you want to do? You want to answer questions, or do you want to go into the?
So maybe we go to the live to the
Problem from practice?
Problems from practice, because I think, or do you want to answer some questions about the
I can
future?
answer any questions.
Yeah,
So
perhaps about the future, because it fits content-wise.
yeah,
right?
okay, let's go. I'll do Hemdeep's one. Do you accept students into the blended program who haven't worked as supply chain analysts? Yes. Yeah. Prior experience in supply chain is not a requirement. I heard you need to know Python for SC0x or 4x. Which one? Neither. You don't need to know Python. I'm trying to think if we're finding more people know R or Python and are doing more coding. And to be honest, our 10-month residential program and our blended program, we're now teaching Python. We're teaching it in January. I don't know if you knew this. Yeah, Sergio is going to teach the course in Python.
Nice.
Because we're finding that companies really want to know, want people who can handle large pieces of data, and that requires some coding language to kind of tie things together. So for our SCX courses, you do not need to know Python. It's a good thing to know. It's a good thing to know, and we're finding
it's one of the most flexible languages that you can apply to data sciences, and I enjoy it very much. I like it.
I saw something about the key concept document. Did you kill that? Okay. I think that's it for now.
Okay. So let's move to our problems from practice then.
All right.
So we got a lot of problems from practice from our learners. We selected a couple, and we'll see how we go through them. So our first problems from practice is submitted by Wisdom G. Dube.
Dube or Duby? I don't know how you pronounce it.
Yeah.
I'll say Dube.
Dube. Okay. Some French touch. And it's called Andrew Poultry Farm. So it's about a family-owned chicken farm who sell chickens to their customers at $7 a piece. So it seems to be US-based, but it's a small entity, and they're trying to grow. Currently, they are doing 100 chicken in a batch, and it takes them 6 weeks to bring them to the target weight. So that's essentially the production cycle. They buy 100 chickens that are 1 day old at a total of $105, so $105 per chicken. And then they have additional costs, like the different feeders that they need at different stages of the chicken's life cycle, antibiotics, some electricity, transportation costs, salaries for their workers. That's in the table. That's the additional cost that we have over that six-week cycle to actually grow the chicken to the finished, to the target weight. And then they face currently 100 chickens per 2 weeks as demand, so 50 chicken a week. It seems to be deterministic in this first exposure. We'll discuss about that later. And what they want is they want to sell their chickens fresh. So it's one of their important objectives. So within a 2 weeks time frame, they want to push out the chickens that have the target weight. Otherwise, they lose their quality. Or, so that is when they are slaughtered, or they need to be fed continuously, which then incurs additional costs and maybe also some weight problems or something like that, that they get too big. I don't know. I'm not an expert on chicken. So they're interested also in growing, expanding their business. Seems to be working well in the last 2 years as to Wisdom's exposure, but they are currently having a 600 chicken set limit of how they can produce. That's like a capacity constraint, if you will. And in the end, they have a capacity constraint on also the refrigerator where they can only store 40 chickens. So it's kind of at the end they need to figure out when to slaughter them so that they don't throw them away, but they don't need to feed them. So there is some kind of dynamic at the end going on. So the major questions that Wisdom posed to us was, well, how many chickens should you actually produce, especially given also the question of how you expand your business, how to set the optimal price, because currently they're working on a $7 a piece question, and that connects, the pricing question connects to the inventory question, because they need to figure out how to hold the inventory and whether to provide discounts and what is with salvage costs and something like that.
Yes,
so this is kind of a rich problem, I think, and our learners already started voting on how to attack the problem. With a pretty clear idea of, well, that seems to be a constraint optimization setting.
Yes, but only very few of you have answered so far. So I want to give you a few seconds because I know we have, we have at least 60 or so.
60 we had in the first.
Yeah,
we had around 60.
So I'll give you some time to answer those. But
the problem.
But what I love about this question is it could go in many different ways. And so when I first read this and I emailed back to Wisdom to understand, because the devil's in the details. Because if I had to solve this right now with someone with a gun to my head to figure it out, I would say buy 50 chickens a week, right? Because the idea is every week I'm going to have a demand for 50. So if I bring more in, right, then I'm going to have to do something to them. So the real basic choice when I first looked at it is, do I want to buy 100 chickens every 2 weeks or 50 chickens every week?
Yeah.
And I could figure out what the difference there, and that's what an economic order quantity that we teach in SC0x will tell you. But what we don't have here is a fixed cost. So let's say I had a fixed cost that it cost me $10 plus $1.05 per chicken, right? So if there was a fixed cost to make the buy, then I would probably go to buying every 2 weeks, to be honest, 100 every 2 weeks instead of 50 every week. The thing about doing 100 every 2 weeks, at the end, I've got 100 chickens that I've got to sell within 2 weeks. And so some of them will get a little old, right? And so that's a challenge. Just looking at it that way, so first time I looked at this, I said, well, it's either 50 a week or 100 a week. You can think of it as a constrained optimization. Your objective function would be something along the lines of maximizing, right? 7, which is our revenue, the 7 a piece, minus, and the cost, I think it is $1.05 plus $5.19. I think if you add this up,
all the costs, 520 and divided by 100, then it's
So then, so you're maximizing some number, and that number gives you a profit margin of about 60 cents, something like that, because that's 75 cents roughly a chicken. So if you have something, if you're unconstrained, you're going to do as many chickens as possible because you're making 75 cents per. So what's going to constrain you? So you could say, well, I'm constrained to 600 because that's their capacity, but that's not really what their capacity is because they can't sell that many. So they would lose those. So your capacity, as I first look at it, that limits it is your demand. Yeah. The demand 50 a week, that dictates everything. So when I first looked at it, it was, okay, do I order 50 every week or 100 every 2 weeks? Because then I'd be steady state. Yeah. Does that make sense?
Yeah, absolutely. And the only thing that is to add here is probably, well, if we're growing our business and demand picks up, we're probably going to increase the number of chickens that we have per week, and it follows your rationale. If it's 75 demand per week, then we produce 75.
Yeah, but Alex, the other thing that I thought was interesting is, we say we have 2 weeks, but I'd have to ask, because now, like I said, the devil's in the detail when you do these things. Can I actually buy chickens every week? Or do I have to buy them all at once? And is it every 6 weeks? So that's one issue.
It looks a little bit like he can only buy batches of 100 one-day chickens, right? Because otherwise we would have been given 105 per chicken.
Yeah, that's true. So
If he has to do that, then he's going to be forced to do every 2 weeks.
Yes.
And if he buys, but you wouldn't want to buy 200 because then what would that mean? You've got 4 weeks of chicken right there. And so, but the other thing I was going to bring, let's say I have the chicken after 6 weeks. Let's say I have 100. So I have 100 chickens now. After like a week and a half or 2 weeks, the ones that aren't sold, can I put them in the refrigerator and get 2 more weeks? Or does their 2 weeks clock start?
Yeah.
Right. You see, so something as simple as that, when does the clock start? Can it be 2 weeks live and then 2 weeks refrigerated?
Yeah.
That'll change your strategy.
Yeah.
The other thing is we don't know how much they're fed. We need to know a cost there because there's also keeping them alive. If that's the case, you want to keep them alive a little longer because then you always have 2 extra weeks.
Yeah.
And so maybe you want to minimize that 40 chickens. You only kill the old ones.
Yeah.
The ones that are hitting their 13th day. That's what you throw in there.
First in, first out.
Yeah. And you try and sell those first, right? You try to sell your old ones. We did a project for Hershey's chocolate, and it's very similar to this problem. Strangely, they produce big, massive blocks of chocolate ahead of time. And you wouldn't know this, but when they make candy bars, the shelf life really matters. And so when they sell it to a store, different candy will come from different runs of the base chocolate. So they'll have different shelf lives. And the question they asked us to try to solve was, do I give my oldest chocolate, which has the shortest shelf life, to my best customers or my worst customers? And the best customers are defined as those that turn really quick versus the slow ones. And the answer is, generally, you give your oldest chocolate to your customer that turns the fastest. And because they don't need the longer shelf life, which is kind of counterintuitive. You think you would give those guys your longest shelf life, but it actually doesn't work that way.
And in that discussion, then the refrigerator capacity becomes relevant, right?
Yes.
Because then you need to decide, do I slaughter the chicken and put it into the refrigerator, and how much can I store there?
Yeah.
Or if there is overflow, then I need to feed them continuously. So that there is going to be a trade-off with the refrigerator capacity.
So then the next thing, if we want to consider, I emailed Wisdom about this. I said, it's not really 50 every week. It's 50 plus or minus, right? We know there's going to be a distribution. So what if it's 50 plus or minus 10? So if you assume a normal distribution with a mean of 50 and standard deviation of 10, now your problem gets a little more different, right? And so now you want to figure out, how much do I want to stock? And so this gets into a problem that we look at in very much in depth in SC0x called the news vendor or the single period problem. And what we'll show you then, I'm not going to go into too much detail, you're going to make a trade-off, because that's what SC0x is all about, making trade-offs. And there's two costs: cost of having too much and cost of having too little. And so the ratio between those is actually the cost of shortage over the cost of shortage plus the cost of excess tells you what the critical ratio is. And the critical ratio is how much of the probability distribution I cover. And that will optimize or maximize my profit. So it's really an interesting problem. And we talk about it in week 5, week 6, or I think right after the midterm, we get into this. It's a great model. And it's, again, doing the trade-off of having too much and too little. And that's where we get into the optimal price. For right now, my optimal price, given the information I have, is $1 million, right? Because if I assume chickens get sold, charge what you can. We need to know some more information about what an optimal price would be. We need to know, it's an unconstrained optimization, right? So if I have my maximize and my 7 minus whatever, instead of the 7, it's now a variable X, right? My optimization will set X to infinity. I have to have something that keeps it constrained. And so we have to see what the market can bear. And so that question, you could go to regression to look at comparable products. I don't know. That's something to come beyond the scope.
Yeah, so you need to kind of figure out how demand reacts to price to give an answer to that, right?
Yeah.
But maybe we can also talk about the discounts question, because it's kind of the end of that answer that we gave with the constraint optimization. The question of when to slaughter the chicken and put it into the refrigerator kind of interacts with whether to use discounts or not, right? Because I could come up with the idea, well, if this chicken is slaughtered and sits there for, I don't know, 10 to 12 days already, I may come up with, well, can I offer a discount for that? And how does that impact my inventory then? my inventory decision.
Yeah, so when we go over the news vendor problem, essentially what you're describing is the added cost of excess. So think of it this in general terms. I've got two costs: cost of shortage when I don't have enough, and what is my cost if I don't have enough chickens for the demand? I lose the potential sales, potential margin. And so this is what, 75 cents a chicken. So if I don't have enough chickens, I'm giving up that much profitability. What about excess? Well, the idea is if I have too many chickens, then I'm going to have to throw them away, right? So I lose everything. So my cost. But if what Alex described is I can sell them for, not $7, I can sell them for $5. Then what that's going to do, your cost of excess goes down. And so you're going to essentially, as your cost of excess goes down, you're going to get a little more. You're going to say, instead of 50 chickens, I'd have 60 chickens. So what you'll see is as you change these levers, it's going to change whether you order more or less based on your risk. So if you're selling it for $20 a piece, right? $20 a chicken, then you would naturally want to have more because then you don't want to miss out on that huge margin. If your cost of having too much was more than just losing the chicken, you had to do something else, decontaminate the farm or do whatever because you have too many chickens running around, then that would drive you the other way. So again, it's just a trade-off based on the trade-off of these different costs. Cost of too much, cost of too little. So it's a very rich problem. And
one of the cool things is what we're going to do is we're going to connect that logic to service, right? Mm-hmm. Because essentially what you're describing is how do we want to serve our customers, and it's determined by the economics behind our problem, right? The more we are hurt by having too much, mm-hmm. So we're not so much interested in service, but reducing our inventory. The more we're interested in making the profit, because the profit compared to what we lose is not so interesting, the more service we want to bring out. So we're going to connect that economic logic with service levels, essentially.
And then service level, that's a great point. So that probability distribution of demand, I said how much we cover, that's a metric of level of service that we'll spend a lot of time in SC0x. What percentage of the time will I stock out? So it's called a cycle service level, and we'll spend a lot of time on it. But what is the probability that I won't stock out, that I'll have enough chickens? And so that's known as, like I said, cycle service level. We can also look at fill rate, all these other metrics, but they all tie to the same thing, looking at that demand distribution. Yeah. So there's a lot more we could dive into this, but hopefully what you're seeing is how we think about it. Yeah. And so depending, you could use all these different tools to come up with something. Some people said queuing theory, and you could think of a queue because essentially number of chickens in, you could think of the processing time, and then you could also put an alternate queue for the freezer. And then, so you could do something interesting here. But again, it's the devil's in the details. So you need to know more details will help you model this. Yeah. All right.
Sounds very good. Do we have questions that go directly to what we've discussed here, perhaps?
I don't see any. No, not on this. All right, let's go to the second problem from practice.
Yeah, but the second problem, I think it interacts pretty well with what we've discussed in the beginning about constraint optimization. So this is given by Gino Beltran, and it's about large-scale network design problems. So Gino faces in his work different large-scale scheduling problems. So in one example, he gave it abstractly, which is totally fine, is that they have 20,000 different products or SKUs, or stock keeping units, over 80 production plans with 10 to 20 ingredients or parameters per product to set, with 1,500 total number of ingredients across all the products and 5,000 points of sale. So just with these numbers, I can just envision how large that graph would look like if I would draw it out, right? A worldwide network of production plans and points of sales that you have to model, like a big company like.
Yeah, but there's so you never have a model, a tool that solves this whole problem. You're either going to solve the inbound, so that's getting from where you source things in, using a bill of materials into production plan, or the distribution plan out. So I've yet to see a company, I don't know, Alex, have you seen one that really tries to model the whole thing down to distribution? Because they're usually very disconnected once you create the finished product. But so usually what we'll see, and we'll see this in SC2X, you kind of divide this in half. So you look at coordinating all the, let's see, the total ingredients. It doesn't say how many vendors, how many sources it comes from, but usually it's like a, usually a ton of raw materials locations, goes down to very few production plants, and then goes back out to a lot of points of sale. So it kind of looks like those two diamonds together. And so having 20,000 SKUs in 80 different production plants, my guess is with that many production plants, you're delivering locally. I mean, there's no reason. This looks like food, so you're probably doing a lot of this within a region. So you can probably decompose this problem, to be honest. Because if I have, say, a production plant in, I don't know, Shanghai and something in Omaha in the United States, they're not really going to interact, right? They're going to be separate. So one thing when you have a problem like this, can I segment? Can I isolate and solve some of these problems independently, or do they connect at some point? The second thing is you want to look at the SKUs. 20,000 SKUs. A SKU, stock keeping, you will talk more about this in SC1X, could be just a different packaging. It might not be that different. So you want to look at families, things that are like common. And we'll talk about this in SC2X, because this is one of the critical things when you do a network design. How do I group different products together? Because you can't model each individual SKU. Like if I'm doing shoes, a shoe manufacturer, every size is a different SKU of the same thing. I'm not going to model them that differently. I can group them together. And so that's one thing. Having 80 production plants. The other thing, it doesn't say what the problem is they're trying to solve. So are we trying to solve roughly some rough estimation of what the costs are going to be? Are we solving how things should flow, from which plant should make which products going to which distribution centers and flowing it down? Or are those set and we're just determining when to do it? Is it truly a scheduled plan? So they're totally different time frames and they use different techniques.
Yeah, and they would also probably, the aggregation idea is, I think, very important here, right? If you're planning a network, then you're working on an aggregate level, so you can probably consolidate SKUs, maybe separate different production plants, and not separate different production plants. Yeah. If you're working on that specific scheduling problem, you can probably go and look at each production site individually.
Right. And so the second question here, can these be solved with software like SAS or Ample? Maybe, but I wouldn't. These problems are so big, and there's specialty software for this, and we'll talk about them in SC4X. But companies like SAP, German company, they have something called APO, Advanced Planning Optimization, APO, I forget that P, Advanced Production Optimization, I think. Anyway, there's different tools in these that are out there specifically doing, say, production planning or flow optimization. Companies like Oracle, JDA, which used to own the i2 tools, which used to do a lot of this. There's a lot of specialized software that is used for this. SAS and Ample are generic tools. SAS is more like an analyst tool. Ample, except for forecasting, SAS is used in production for forecasting. It's one of the top forecasting tools out there. Ample is a really production grade simulation, but no one that I know uses simulation to solve a scheduling problem, because a simulation doesn't give you an answer, right? It tells you what will happen if you do a certain thing. So I haven't seen, have you seen simulation used for this? Yeah, because just the question is, I want to know what the optimal schedule is, not what will happen if I do something. So different tool.
Yeah. So I think perhaps instead of simulation, it's about heuristics, right?
Yes.
How can I get to
if you can't solve it optimally.
Exactly. Yes. So maybe not simulation, but heuristics is the right word to look for, and look up different methods and techniques to solve the problem. Maybe not optimally, but close to optimal.
Yeah, and I think I talked about this in SC0X. People think, optimization and then heuristics bad. Even for a large scale problem like this, the dirty little secret is if you use large scale combinatorial optimization, at the end of the day, you're not solving it optimally. You're solving it as close to a gap they call it it's the integer programming gap between what you solved and what you know the unconstrained linear solution will be. So you actually don't solve it for these real large problems exactly. You get it real close. So heuristics aren't a bad thing.
Yeah.
All right.
Yeah.
What else? Anything else on this one?
No, I think we're good. Do we have questions about?
I don't see any on this. Why don't we do the last one, because it's pretty quick too, isn't it?
In terms of introduction, maybe takes some time, but perhaps in terms of discussion, it's quicker.
And then we'll do questions.
Yeah. So this is by Molina Ibanez, and it's talking about forecasting ordering for a Spanish grocery store chain. So they are operating for the whole state of Catalonia in Spain, and they have an automated warehouse to manage all the meats, fruits, and vegetables that are dispatched to different locations. So they have 40,000 storage locations in that facility and have around 1,700 highly perishable SKUs that go through that warehouse. Perishable means shelf life is very, very short. So meats, fruits, vegetables, they have like 1 to 2 weeks, perhaps, if they are cooled down. I don't know. I'm not an expert, but something that.
You're not an expert on chickens or.
I consume them. I can actually do something with them in the kitchen, but I'm not an expert on how to store them. So they have that guaranteed shelf life that they have to deliver to in a store. Otherwise, they have to sell it out at a discount. So we're coming back to Andrew in that discussion. And a high turnover. So 90% of the SKUs go through the warehouse within 1 day. So a lot of volume that is going through that. And we see that the volume varies a lot.
Yeah.
So, of course, on one hand, seasonal, depends on winter or summer. He or she, I don't know, brought the example that meats are more important in the winter, and in the summer it's more about the vegetables. And it varies also across the week, right? Because at the weekend you need to have a lot available. So Thursdays and Fridays, a lot of material is pushed out, whereas on Monday it's not that important. So the key here is that they have to dispatch the trucks to different locations, and they have different lead times, because far away trucks need to be dispatched earlier than close by trucks, or trucks that go to close by.
But they go on the same day. We're talking 3-hour difference.
Yes. So
right?
what he is saying, well, we have set these slots of 12, 13, 14, and 15 where we push out the different trucks. And his core question is how much inventory to hold in the warehouse to meet the critical cutoff time. So because it's again that question of having too much and having product that sits there too long, but also having too little and not being able to push out in time.
So to me, the critical question that isn't answered here is where's it coming from? So if they're a retailer, they're sourcing this. So I think the limiting thing is how quickly I can source it, because if they're shipping, it looks like a 1 day. Was it the third, fourth bullet point?
90%, yeah, 90%.
1 day. So the nice thing about this, so I would ask, with any of these, you got to ask more questions. So I would ask from the supplier side, how quick is their response? Do I have to order it a week in advance? Can I order it the day before? If I can have the shorter my lead time for ordering, the more flexibility I have. Same thing on the other end. When do the orders come in? Do the orders come in a week in advance, or do I know it at 12 o'clock, what gets ordered? So as I have more lead time there, that helps me, right? Because I know. So for the procurement side, having a shorter lead time is good for me, because then I don't have to do as I can wait to make my decision, but I want as much lead time on the other end. So knowing those two things, to me, that would dictate everything. Because what we'll see is lead time is a critical component to determine the optimal inventory level. As you have a longer lead time to get something, if it takes a week, if I order something and I don't see it for a week, that's different than if I order something and I get it for a day. Because if it takes a week, then I've got to keep a week's worth of demand of supply here to handle the demand while the thing's getting to me, right? And so as I shrink my order lead time, the amount of inventory I need goes down. As I increase the amount of lead time I have to place the order, of what to put. So let's say my customers let me know a week in advance exactly what they want. That's much better. So I think you'd want to look at the trade-off between those two lead times. And so if the lead time to order is longer than if the lead time that the customers give you is longer than the lead time you give your vendors, you're golden. If it's the other way around, you're kind of screwed, to be honest.
Yeah.
Anyway.
It's kind of the difference between having a warehouse just for purposes of recombining different truckloads,
right,
or whether it's actually serving as a buffer between your supply and
point.
your demand, right? So that's kind of
if you can go to it, if you can go to a total flow through, that's the best. And we talk about this in 1X, and when we talk about DCs, the whole idea of cross docking. This is the idea. If you can cross dock it, do it, and keep just minimum amount of the things on hand that takes longer to procure. All right, I'm gonna start asking questions.
Yes. Let's see.
Is that okay?
Let's see what the questions have. Let's take it from the top, probably.
Running simulations. What level of aggregation do you recommend? Example, do I consider the individual distributions of each individual source or aggregate? Aggregate. It depends on the problem.
But it kind of ties into what we discussed for the second problem. Depends on what you want to answer. But make only sure that you have enough detail that you need, but not more. Right? Because it's computationally expensive.
There's an Einstein quote. Your model should be simple enough, as simple as possible, but not over too simple. It has to be complex enough to capture it, but you want it as simple as possible.
Figure out that golden spot, that trade-off is important, right?
All right. How can we perform inventory optimization using optimization tools? Are we going to cover this in SC1X? Yes, you're going to cover this a lot. When you say optimization tools, what we'll do is we'll show you how to solve it mathematically, and we'll do it in like Excel or some spreadsheets, because you'll do it if you have like SAP, your ERP systems in a company will be doing this generally. They'll be giving you what the order quantity is, given the lead time and all these other characteristics. We'll show you what the math is. So yeah, you'll do that.
And we're doing that in SC2X, we're doing that for production planning too, right?
Yes,
so we're not only doing that in inventory management and show you how that works and how you can implement that on a smaller scale if you're not using some advanced software like SAP. And we're doing that in SC2X for production planning and scheduling, same thing.
So EF asks, will later courses give advice on communicating these results findings to company leaders who may not understand the underlying methods? Not really. We do that. We think, so online education is awesome. It's the best way to learn everything you've learned so far in SC0X. And personally, online education, online courses, video courses are horrible for teaching change management. And that's what you're talking about. How do I convince someone to make a change? And we talk about that. That's why we run boot camps. That's why we do live events like this, because it's better to have interaction. We just ran a course this morning for a large beverage manufacturer where we had 30 students and we could see them live and we could interact. That's the best way to understand how to do these change management techniques. We can talk to you about it and say, here are some tips, but it doesn't work as well unless you really discuss it. Does that make sense?
Yeah, it's a setting for a classroom.
Yeah. How can these concepts be applied to urban design and planning? Well, all the stuff we did for routing, when I actually showed algorithms and approximations, I killed two birds with one stone there, because I wanted you to see network optimization, and that's a way to teach that really quickly, because that's a great skill to have. So a lot of the urban design uses some of those approximations, but a lot of the other stuff, it really doesn't apply. The techniques apply. You can use regression to find out what flows are. When I used to be a passenger transportation guy, and you develop the gravity model. You determine what generates traffic and whatnot for urban planning, and you're using regression, you're using optimization, all those things, but it's very far away from supply chain. Any reading materials about books for large scale problems? It depends what you're talking about. So, Gino, you're the one who put that question in. I recommend going to the vendors, go to SAP, go to Oracle, go to JDA, because I think you want to understand how to actually solve those problems, not the large scale math that's sitting underneath it. If you want to, go to Nemhauser and Woolsey. It's out of Georgia Tech, and they do combinatorial optimization, and it's really hard, but that's at the heart of the optimization. If you want to find out what's done in practice, go to the vendors, Oracle, JDA, SAP.
A simulation related question here. Is simulation used to check the performance of your inventory policy?
It can be. It can be. Yeah, sure.
That's actually a good way to use simulation, right?
Yeah.
To check a certain instance.
Yeah. So if you do, when we do EOQ, which determines the optimal quantity to order, you could actually run a simulation and you'll come up with the exact same answer, right? It depends what you give as the underlying distribution. But yes, it's used to check that. The first question, you've obviously taken some of SC0x, because the power of two technique, I'm not going to go into it. It's a technique, a nice approximation technique that we talk about for inventory. For Class C items, sure, that makes sense. I don't want to go into that though, because that's not really relevant here.
So Param has also an interesting question about the chicken problem, the first problem that we covered, about how to factor in the mortality. So if we have that deterministic setting, we buy 50,
so they die within,
yeah. So if they die within, then there is a probability that a chicken dies. So we have a second uncertainty. It's like if you generalize that, it's a quality problem, right? So you not only have demand uncertainty, but you have also like production quality.
Yeah, let's say 10% die. Then if you know it's always 10%, then what do? You order 10% more.
That's right. You can just.
However, SC0x, we actually do this problem. Have you seen SC0x? No. We do the chicken problem. And so the problem, I use it to illustrate system dynamics, because here's the dynamic is, as I have more chickens, they tend to cross the road. And as more chickens cross the road, they get run over. Right? And so there's this dynamic. And so we do a little more sophisticated optimization here, because the number that die can be a function of the size, and so that makes it more complicated. And we talk about that, what the system dynamics are in SC0x. So stick around; it's an interesting question. Is there any course referring to WMS?
What is WMS?
A warehouse management system.
Ah, okay.
I talk about it in SC0x, and I talk about distribution centers in general, just kind of one lecture in SC0x in week 9 or 10. So yes, a little bit. Not too many people do too much on WMSs, to be honest. There's John Bertoldi, Bartholdi out of Georgia Tech, and it's in a reference for the SC0x. SC0x key concept document. He is the master, and he has a great book that's available online that's called Warehouse Science that you can look at. So go to the key concept documents. You have access to them on all the courses, and then look at the end for the for SC0x for the warehousing section, and that'll give you the link for that. I think we would need to have the geographical location of the suppliers, density of the products where we need. You may need to revise this location. I don't know what the question is. So excellent point, Steve. You're probably right. I think if that that probably refers to this. Yes, you're exactly right. If it refers to this problem for practice 3, you're exactly right. Knowing we don't actually need to know where they are. We need to know how long it takes. Time is all that matters. Unless it's crossing a border, you get some other things. All right.
Demand fixed. We covered that already, because we can charge whatever we want, right?
Yeah, exactly. Yeah, we covered that. Yeah, excellent point, Ruben. Do we need to buy more than demand to address unplanned expense? Yes, exact. We covered that as well. Same thing. We covered it. Last question. Here's right for PF3. We answered that, didn't we?
Yeah, we did. Yes.
Yeah.
So
it's all about the lead time. So this one for the Spanish grocery store, it's comparing how much lead time you've got to give your suppliers and how much you can give your customers.
So we have that.
So you get to pick the last question.
I get to pick the last question. Let's do the heuristics versus optimization. What's the threshold? When do you switch from a heuristic to an optimization and back?
Where did it go? Oh, that's
from Giovanni, the third one, right?
When you can't solve it, well, a heuristic can be an optimization, so it's not an exact optimization, right? So But I think if you can solve something optimally in a short amount of time, do it. The benefit of a heuristic is when you can't. And so, like when we did the news event, we did traveling salesman problem. You can't. It's very hard to solve that optimally, actually. So an approximation, a heuristic works well. So it's really, if I can solve it exactly within the time I'm allowed to solve it, do it. We do a project with Walmart where we determined where they use their for-hire fleet and their private fleet, and we can solve it in 2 hours exactly. Now, if they wanted to know within 10 minutes what that was, we'd have to go to heuristics. But because a 2-hour runtime is sufficient for them, we could do it optimally. So it's really a function. Let me answer the boot camp question. I was just there, and we ran a boot camp. I was in Ningbo 10 days ago, and we sent this note out to people, and we didn't have that many show up. We ended up with 20 people. So I've been in Asia, I've been in Europe, and we've been doing these boot camps. So you need to pay attention to your emails, because I ran one there. I didn't see you there, Sherry. But we're trying to do these more across the world. We're trying to see what the demand is, because it takes a lot of effort for us to go there. And so we have to balance that out. And with that, I'll hand it over for you to wrap it up.
Perhaps we can take a quick look at the initial poll that we had, where we covered the different words.
Okay.
Word cloud.
The word cloud.
Yeah, because it fits very good.
Oh, back to the very first.
They like us. They say we're awesome, and we are supposed to teach everybody here at MIT how to do a course effectively and efficiently. So I think challenging is the best way to describe SC0x, and that's essentially your first sentence today. We threw a lot at the students. That is our toolbox, and we are going to use that toolbox to go through the courses.
All right. Well, guys, I hope you liked it. Hope you liked SC0x. SC1x is more fun. We cover much more real things, and the math is not as the focus. The math supports the analysis.
Yes.
It isn't the focus.
And we are going more into different methods and problems that you're facing every day.
Awesome.
So thank you very much, Chris, for taking the time.
This was great.
That was awesome. Thank you very much, learners, for attending, for being so active. We appreciate that very much. And we wish you good luck with the final exam, and hopefully see you all in SC1x, which starts tomorrow. Thank you very much. Bye-bye.